Today we'll be having a look at the following graphing problem. So we have to sketch the graph of the quadratic equation y equals 2x squared minus 3x minus 5, and using that sketch the graph of y equals the absolute value of 2x squared minus 3x minus 5. Okay, so we can start by sketching this quadratic. So first thing you can try to look for is if you can factorize this quadratic. And to attempt to factorize this quadratic, we can try to find two numbers that add to give its coefficient of minus 3 and multiply to give the product of these two coefficients. So multiply to give 2 times minus 5, which is minus 10. And if you test some values out, eventually you can see minus 5 and 2 add up to minus 3, and they also multiply to give minus 10. So what we can do now is we can convert the minus 3 as a minus 5 plus 2. So we can write minus 3x as minus 5x plus 2x. So we can split it up. And now we can see this part of the quadratic has a factor of 2x minus 5, and also this part of the quadratic has a factor of 2x minus 5. So we can completely factorize the quadratic as 2x minus 5 times x plus 1. After factorizing this quadratic, this immediately gives us the roots as well. So one of the linear factors is 2x minus 5, and this gives us a root of x equals 5 over 2. And the second factor is x plus 1, which gives us a root of minus 1. These are our two roots, or x-intercepts. Now we can try to find the y-intercept, so where it crosses the y-axis, and this can be found by substituting x equals 0. So if you put x equals 0, we'll get y equals 2 times 0 squared minus 3 times 0 minus 5, and this will give us minus 5. This is where the y-axis is crossed. You can also find the vertex of the quadratic, so this is where the line of symmetry will be. And the formula for this is x equals negative b over 2a. And the value of b is minus 3, and the value of a is 2. So if you substitute those in, you'll end up getting negative 3 over 2 times 2, which is equal to 3 times 4. Now we can substitute x equals 3 over 4 to get the y value. The y value will be 2 times 3 over 4 squared minus 3 times 3 over 4 minus 5. And this is 9 over 8 minus 9 over 4 minus 5. And if you just make it all under common denominator of 8, you'll end up getting negative 49 over 8. Okay, so this is all the information we need to sketch this quadratic. So I've got the sketch down here. So we've labeled the roots of the quadratic as being minus 1 and 5 over 2, and we've got the x-intercept of 3 over 4 here. X-intercept, the vertex of 3 over 4 for the x value, and minus 49 over 8 for the y value. And the quadratic is concave up, or it's shaped like a smiley face, because the leading coefficient is 2, and 2 is a positive number, so that's why it's a concave up. This completes the graph of the quadratic, but now we need to find the graph of the absolute value of 2x squared minus 3x minus 5. And if you can recall the absolute value function, you can remember the absolute value of a positive number or 0 will just be itself, but for a negative number, the absolute value will be the positive version of the number, or flipping the sign back to positive. So for example, the absolute value of minus 1 will be 1. So what we can do is the positive parts of the function and the zeros will still be kept the same. However, the negative parts have to be flipped. They have to be reflected over the x-axis. You can reflect the negative parts. Reflect negative parts over the x-axis. So we can see the negative parts are down here. And to reflect it over the x-axis, it means this vertex negative 49 over 8 will be flipped up to 49 over 8. So we have to draw it a bit higher. So it's up to 49 over 8 here. So now the vertex gets flipped up to this point over here. So we can flip this entire orange region here. We can flip the whole thing like this. And now the final graph of the absolute value function will be, I'll do it in blue. So the blue part is the absolute value function. So the blue part is our final answer, which is the graph of the absolute value of 2x squared minus 3x minus 5. Okay, so that completes the solution to this graphing problem. So hope you enjoyed this video. Thanks for watching, and I'll see you next time.